Hey guys over there watching my video, I am Shreya and welcome to my YouTube channel Codeweb with Shreya. So from now we are going to start a new series on seminar topics, and this will go parallel with our previous topic on HTML. So our first seminar topic will be brain computer interface. So coming to the contents of this seminar: introduction to BCI, BCI model, early work, BCI approaches, applications, and conclusion. So BCI is nothing but brain computer interface. So, introduction to brain computer interface. Brain computer interface is a fast growing emergent technology in which researchers aim to build a direct channel between human brain and a computer. So, this is a kind of technology where scientists are trying to build a connection between our human brain and a computer system. A brain computer interface is a collaboration in which a brain accepts and controls the mechanical devices as a natural part of its representation of a body. So in this system what happens is the machine takes the signals from the brain and acts as the brain cells. So you can see this BCI model. Signals are taken from the brain and with the help of some algorithms they are decoded and sent as a mechanical signals to the machine, and the machine acts as the mechanical signals. Here the machine is a wheelchair. So early work. Algorithms to reconstruct movements from motor cortex neurons which control movement were developed in 1970. So what happened in the 1970s is algorithms are constructed. Why these algorithms are constructed? That is, we get some signals from the motor cortex neuron. In order to decode these signals, the algorithms are constructed. The first intracortical brain-computer interface was built by implementing electrodes into monkeys. So any research is not done directly onto a man. First it is tested on to some animals. So this interface was tested with the help of monkeys. After conducting initial studies in rats during 1990s, researchers developed brain-computer interface to decode brain activity in monkeys and use the devices to reproduce monkey movements in robotic arms. What this means is they have created the algorithms in 1970s, and in 1990s they have tested this interface whether it is working on the rats or not. After it shows some result on rats, they have started capturing the movements of monkey into the robotic arms. The robotic arms behave as the monkey's brain work. So in this man, at one hand his muscle is damaged and at the other hand this hand is replaced by a robotic hand. Here they can perform two situations, either placing an electrode over his muscle here or putting an robotic arm. Here if you place an electrode here, what this electrode does, it sends a signal to this neuron over here. So if the man thinks of moving his hand, so this signal will be transferred here and the movement is possible. And here directly an robotic arm is connected. So the electrodes are placed here and directly the instructions are being sent to this hand. And here what this man is trying to do is he is trying to control the cursor by his eye movement. If he sees to the right, the cursor moves to the right. If he sees to the left, the cursor moves to the left. So he is trying to hit this target with the help of his eye movement. So this is possible because of brain-computer interface. So let's see how this brain-computer interface works and what are the types of brain-computer interface. So there are three types of brain-computer interfaces till date. That is invasive, semi-invasive and non-invasive. Invasive uses the technology known as neurosurgery. Semi-invasive uses a technology of ECOG and non-invasive uses a technology of MRI or EEG. So coming to the first one, that is invasive BCI. Invasive BCIs are implemented directly into the grey matter of the brain during neurosurgery. So for this invasive BCI, you undergo a neurosurgery where the electrode or the BCI chip that is implanted, that is inserted into the gray matter of your brain directly. As they rest in gray matter, invasive devices produce the highest quality signals of BCI devices. So these electrodes are directly placed into the brain. Due to that, they give the highest quality of brain signals, but are prone to scar tissue buildup, causing the signal to become weak or even lost as the body rejects the foreign objects in the brain. Inserting something into your brain would be dangerous because if the body is not adjusting to this foreign object or it is not accepting the foreign object, the signals would be permanently lost. So the complete surgery would go in waste. So in order to avoid these kind of problem, they have come up with a better option that is semi-invasive BCI. The electrodes are placed on the exposed surface of the brain. So here the electrodes are not placed completely into the gray matter of the brain, whereas they are placed on the outer surface of the brain. As you can see in this picture, here the electrode placed in the outer surface of the brain. The ECG signal is taken from electrodes placed in the dura or in the arachnoid. So these signals are collected from this dura or the upper part of the brain. ECG is also known as electrocorticograph. So semi-invasive BCIs would also be dangerous as it needs implantation on the brain, but in the upper part of the brain. So in order to avoid these problems, we have come to non-invasive BCIs. The sensors are placed on the scalp to measure the electrical potentials produced by the brain, EEG or the magnetic field. So here what happens is it does not require any neurosurgery or any insertion of external objects onto your brain. It has some sensors which are put on the top of your head and it collects the signals from the scalp. We have EEG helmets which collect the information from the scalp. The EEG signal is taken placing electrodes on the scalp, so on the most external part. So as I have said, here no need of any surgeries or the sensors are directly placed on the scalp. So as you can see here, this man is gaming only with the help of his brain. He doesn't have any keyboard or any mouse with him. He's just playing with the help of his brain. As you can see here, this is known as an EEG helmet. EEG is nothing but electroencephalography, and these signals it shows in the form of a graph. So they are known as EEG signals. So coming to the applications of BCI. BCI provides disabled people with communication, environment control and movement restoration. So the people who cannot speak or who have lost their movement can use these BCI applications in their day-to-day life. Provide enhanced control of devices such as wheelchairs, vehicles and assistant robots for people with disabilities. Nowadays we are able to see these kind of wheelchairs where a person can control the wheelchair with the help of his brain. This is possible because of the BCI technology. Provide additional channel for control in computer games. So these BCIs are also used in computer games. Control robots that functions in diagnosis of in some situations such as underwater or extreme heat or cold condition where man cannot survive. So these kind of BCI robots can be used in that situations. So coming to the conclusion, BCI is an advancing technology promising paradigm shift in areas like machine control, human enhancement, virtual reality and etc. So it is potentially high impact technology. So BCI technology used in machine control, human enhancement and virtual reality. Several potential applications of BCI hold promise for rehabilitation and improving performance such as treating economical disorders, for example depression and anxiety, easing chronic pain and overcoming movement disabilities due to stroke. So with this I conclude. Thank you. If you like this video, do like, share and subscribe to my channel and comment down the topic which you want me to make a video on.